G'day Year 7 mathematicians and welcome to lesson 2 of the week. So if you can draw a straight line under previous work and put today's date and the title of Sum of Angles in a Triangle and a Quadrilateral. Okay, so your first task, appearing on the screen now, is there are 12 questions and there are missing angles on 12 of those. If you can then work out using your knowledge of angles on a straight line, angles around a point, to solve those 12 for me. So pause the video and that should just take you a few minutes to do. Okay, answers will appear now in the middle of the screen, all 12 of those. If you can mark those and double check your answers for me. Obviously I haven't put the degree symbol on because it's a little bit of a hassle on the PowerPoint, but make sure you have in your book, please. Okay, so today we're going to know the angle sums of triangles and quadrilaterals. When we say sum, that means adding them all together, what's the total going to be able to find some missing angles in quadrilaterals, and be able to identify the angle fact needed to solve then some more complex problems later on. So, we have had a look at this in a previous lesson, but worth reminding ourselves, these are our four main types of triangles. We've got an equilateral, isosceles, scalene, and then our right-angled triangle. So you should have had those written down from a previous lesson. If not, you do need to make sure they are written down. Okay, so angles in a triangle. What do we know about these? Again, we've touched on this. All the angles in a triangle will always add up to be 180 degrees. The interior, so that's the inside angles of a triangle, will add up to be 180 degrees. So in the example there, A plus B plus C will equal 180 degrees. So here's some examples then with some missing angles. We know A plus 81 plus 44 must equal 180 degrees. So A, adding those two together, A plus 125 is 180 degrees. So to get A, we'd do 180 minus 125. A then is 55 degrees. And you can just do the final check if you need to. 55 plus 81 plus 44 is indeed 180 degrees. I would like you to write these examples down in your exercise book for me, please, as we go through them. Next one, and this is a common theme that when they're doing find the missing angles, they will use the right angle notation. So you just have to remember that means 90. So B plus 90 plus 37 is 180 degrees. Combining those, we can work backwards and we'll get B is 53 degrees. And then for the third one, this time pay careful attention to those lines. Those lines indicate that we have got an isosceles triangle where two sides are the same length, the ones with the lines on, which means those two angles will be the same length there, same size. So B and B will have the same angle. Those lines indicate that the angles opposite them will be the ones that are the same. So 44 plus B is equal to 180. 2b plus 44 is 180, and then we can do the 180 minus 44 gets us what 2b is. To get to 1, we've got two lots of it, we just need to divide by 2, and so we get 68 degrees for b. Two lots of 68 plus 44 is indeed 180 degrees. Okay, so when you've got those three written down, have a go at the next slide for me there. You can draw them as a sketch into your books and you're going to find those 6 missing angles for me and pause the video to have a go. Okay, so for those we should get as answers 52, 69, 49, 92, 54 and then finally 88. Okay, now this is a question I quite like here. One angle in an isosceles triangle is 30 degrees. What must the other two angles be? Give two possible solutions. Okay, and it might help you there to sketch and label up triangles to make it easier for yourself. Now, I think a lot of you might be able to get one of these, but the idea is we want to see if you can get two possible sets of solutions. Okay, so for an isosceles triangle, we have to think that two angles must be the same. Perhaps the one to go for first is if one angle is 30, we can have another angle that must be the same as that. So we would have 30, 30, and then that adds up to be 60. We need 180 total, so the last angle would be 120. Or it could be that 30 degrees is the angle that's the sort of odd one out, and the other two are equal. So you do 180 minus 30, which is 150, then divide by 2, so you'd have two angles at 75. So you might have 30, 30 and 120, or the other triangle would be 30, 75 and 75. Okay, they must add up to be 180 degrees, and there must be two angles that are the same to be an isosceles triangle. Okay, few more examples on this one, and this builds in some of the other knowledge we've looked at, and it's a bit of a combination of everything. So you've got angles around a point, angles on a straight line, and then you've got angles in a triangle. Okay, so pause the video there, and there's quite a few questions. There are 16 there, and I'd like you to work all of those 16 out for me, please. Okay, so to come up with answers, this is what you should be getting. Obviously the number highlighted with the X is the answer for the degrees, but I've filled in all of the degrees for you on the other ones and perhaps shown you the correct order that you would do them in order to work them out. So in particular on that bottom row, when you're looking for the angle, you would need to do the base of the isosceles triangle first. You know that 117 plus something equals 180 because it's angles on a straight line. That gives you an angle of 63. As it's isosceles, those two angles that form the base must both be the same, so they're both 63. So you do 180 minus 63 minus 63, and that gives you 54 degrees. Bottom right one is a fantastic one again. Angles on a straight line. Got 180 minus 112, that gives you the 68. The angle above that must also be 68 because we've got the isosceles triangle. That leaves then angles and triangles 180. 180 minus 2 lots of 68 is 44, but we're asked for the rest of the angle, the obtuse part of that. And so we're going to do 360 minus 44, and that'll get you 316 degrees. Okay, so on this one, we're going to look into some more complex ones now. Two shapes are connected to their edges as in the diagram below. Calculate the size of the obtuse angle. Okay, so our first clue is we've got the word obtuse, so we should know what sort of range we're looking at. We're looking at obtuse is an angle between 90 and 180 degrees. Actually, going back, I think I made a mistake earlier when I said we were looking at an obtuse angle. That bottom right one obviously is a reflex angle, sorry, because we're looking at over 180 degrees. So that bottom right one, sorry, is a reflex angle. But back onto this one then. Two shapes are connected. Calculate the size of the obtuse angle VWX. So some of you may be able to do it straight away from that, in which case have a go. If some people are quite unsure which angle we're looking at, that's the one we are looking at. They're brilliantly annotated with a perfect curve there on VWX. So pause the video and have a go, and then I'll talk through how we may solve that one. Okay, so first thing I would look at is the angle WVZ is going to be the same as angle WZV. Because we've got an isosceles triangle, those two angles must be the same, and so that would be 35 degrees for WZV. Then we know angles in a triangle add up to be 180. So VWZ, the third angle in that triangle, plus 35 must equal 180. So VWZ is 110 degrees. Okay. WXYZ, the quadrilateral there, looks like that would be a square because we've got four equal sided lengths that are annotated by those lines. Therefore, each one must be a right angle, so it's 90 degrees. Okay, so XWZ is 90 degrees. And then what do we know about all those angles together? It's angles around a point, which is 360 degrees. So to do VWZ, we would do 360 minus 90 for XWZ, and then minus the 110 for VWZ. The rest would be VWX, and we are left with 160 degrees, and that then, of course, is an obtuse angle. It's greater than 90 and less than 180 degrees. Okay, next up then is we're going to have a look at some quadrilaterals. Now we know how to work out the angles in a triangle. let's have a look at the quadrilateral, and then in the third and final lesson of the week, we'll look at polygons, which are more than the 4 sides. We'll look at many-sided shapes, so we'll look beyond quadrilaterals in the next lesson. So on this one, what facts do we need to know to answer this? And then what sort of angle notation will we use? So some of you may know already how to work out what ADC is. So if you do know, feel free to answer it now. If not, come back when we've had a little bit of information and solve that for me. So this is the key bit to write down again for today's lesson. What is the sum of the interior inside angles in a quadrilateral? How can we show this is true using an earlier fact? So there's a quadrilateral. Now the earlier fact we know is about a triangle. The angles add up to be 180 degrees. How about if I drew that line on, we have got 2 triangles. And each triangle must be 180 degrees. Add those together and we've got 360 degrees. So the sum of interior angles in a quadrilateral is 360 degrees. 360 degrees. Now David has a go, and he said the interior angles in quadrilateral are summed to be 720 because he split the shape into 4 triangles, not 2, and 4 lots of 180 is 720. Explain why David's diagram does not then show this. So what is different on this diagram then? Okay, when we're splitting the shapes into the triangles, we want the lines to appear just from one vertices, the corner. So you'll pick one corner and you'll do your triangles from there. So that's where your lines would come out from. These have come from all multiple vertices, the corners. And so we've got a lot of crossovers in the middle, and that's why they've created 4 triangles. If you drew them from anywhere on the shape, you could, in fact, I believe, just create an infinite number of triangles on there. Okay, that's not going to be the case. You're going to draw them all coming from one corner, one vertex. So, if we now know the fact that all angles in a quadrilateral, the sum of all angles is 360 degrees, you're going to need to calculate the size of each angle marked by the letters and find what the missing angles are on these 8. So there's an ABCD first and then a second batch of ABCD. There are 8 in total. So if you pause the video and have a go at those for me. Okay, so well done for having a go on those. Let's put some answers in for you. I've gone in a bit of a strange order, but if you can just mark those for me and put on any corrections there as well. These now get slightly trickier, so I would like you, especially on number 4, because number 3 you can't, but on number 4 you will need to draw those diagrams out. Again, you don't need to use a protractor to make them exact. Just draw them, say, look like that, and clearly show the angles that are given to you in your book. Okay, so pause the video, and there is question 3 and 4 there for you. So, question 3. Key thing here, which of these 3 sets of angles could be the 4 interior angles of a quadrilateral? First things first, what should the 4 interior angles of a quadrilateral be? Well, they must add up to be 360 degrees. So, have a look at the first one. Add all those angles together. Oh, look, that adds up to be 350 degrees. It cannot be a quadrilateral. If you have a look at the second one, add all those together, they will be 360 degrees, so we'll take that. And on the last one, adding all those together, and we end up with an angle that's 370 degrees in total, so it cannot be a quadrilateral, so it's just part B. Okay, number 4, A is 90 degrees. To work that out, what I would do is the bottom right-hand corner, where the 100 is, those 2 angles together must equal 180 degrees, because that's angles on a straight line. Therefore, the bottom right of the quadrilateral will be 80. Add the 3 of them together, 118 plus 72 is 190, plus the 80 is 270. It's got to be 360 in total, therefore A is 90. Very, very similar system for B. All 4 in the quadrilateral must be 360, so you could work out the missing angle in the quadrilateral, and then you would take 180 and minus that angle you've just found, leaving you with B as 63 degrees. Okay, a little bit of true or false here then. So given a quadrilateral there, which of the following equations are correct for the diagram? So there are 5 there. I'd like you to draw that, have the 5 statements there, and explain why they are true or why they are false, giving the reasoning based upon the facts we have learnt about angles. Okay, first up, that one is going to be false. Okay, 81 is not going to be equal to those 3 added together because we know the whole lot must equal 360. That's not then going to be the case. That'll only make it 162. The one below, though, adding all 4 interior angles, W, X, Y, and 81, must make 360. 279 is W plus X plus Y. That is correct. If you do 360 minus the 81, the one that we do know, you're left with 279. That must be what W, X, and Y add up to be together, so that is true. X is 81. Now, it could be, but we have no idea. There's nothing that we know as a fact that shows that at all. So that would be false. Oh, we've done it in the wrong order there. False, sorry. And the last one, 180 equals X plus 81. Again, it could be true, but it's not something that is shown as correct from the diagram. 180 would be degrees on a straight line, but we haven't got the straight line there to show that, so that would be false as well. So, few more complex ones here. So, calculate the size of angle N. So this would be an example of go through because actually the answer's already appeared there. So, first of all, let's recognise we have got an isosceles triangle because we've got those 2 lines. Those 2 lines indicate that the angles opposite them will be the same. So where we've got 103 degrees, apologies, the angle next to it, sorry, must be 180 minus 103, which would give us 77 degrees. So that would be 77, and then as it's an isosceles, the other one will be 77. The 3 together, 77 plus n, must equal 180. So we'll take away 2 lots of 77 from 180, and we're left with 26 degrees to solve for n. This next one, I'd like you to copy the diagram and then calculate EDF for me. And then I'll take you through and you can mark for me. Okay, so on this one, first thing I would look at is DEF as an angle. It's vertically opposite GEH, so that must be 51 degrees. And once again, those lines indicate that we've got an isosceles triangle. So EDF and DFE must both be the same angle. If we did 180 minus 51, we know the total of those triangles must be 129 degrees. They've both got to be the same, so we'll simply divide by 2, and we will get both of them being 64.5 degrees. 64.5 degrees for EDF. Okay, and then last but not least, you're going to work out LKP, and I have just drawn a, well, I'm going to ask that's quite a poor one, a little squiggly line there to show which one LKP is, and you need to justify all the angles you work out, and you can just simply draw them on your own diagram that you're going to sketch into your book. Okay, so for this one, as I said before, there can be various ways of getting to the answer, but it all produced the same answer. So I went first and worked out angles on a straight line there, must add to be 180, therefore that angle is 108 degrees. Okay, next one, those 2 angles are vertically opposite, so they must be the same, therefore that is 85 degrees. Then we've got a lovely right angle already shown there, and angles in a quadrilateral add up to be 360. So if I did 360 minus 108 minus 85 minus 90, I'm left with 77 degrees for LKP. Okay, next one on these complex ones. There's a diagram here and a student explanation of finding the size of angle QPS. Is each stage of the reasoning correct? Could the solution have been more efficient? So first of all, I want you to look over and do you agree with every single step that's there? Have they got it correct? And perhaps could there be a different way of solving it? Okay, so let's tackle this one line at a time. TRU is 125 degrees because angles on a straight line sum to be 180. I would absolutely agree with that. We've got the other angle is 55 on the straight line, so TRU is 180 minus 55, so that would be 125 degrees. Then looking at QRS, that must be equal to TRU because they are vertically opposite angles, so that would also be 125 degrees. Then we know angles on a quadrilateral must sum to be 360, so 100 plus 60 plus 125 plus whatever QPS is 360. Working backwards then, and you'll get QPS is 75 degrees. 75 degrees, so they are absolutely right. As perhaps an alternate method, I may have looked at QRS straight away, and QRS is also on a straight line with the 55. So you could just say QRS straight away there is 125, and perhaps skipped out the first step. You didn't need to work out TRU. Okay. And this is a big last question here. We have got A all the way through to G as missing angles. Okay, and they are in that order, as I think that's probably the most sensible way, is if you did solve A, then B, then C, and worked your whole way through. Okay, you can solve them in a different order, but that would definitely work in that way. So you're going to see how many angles you can solve on there, and we do need a reason each time. So pause the video, and this is one of the last big questions for today. Okay, so angle A, we've got angles around a point. So if we did 360 minus 134 minus 72 minus 90, we get A is 64 degrees. Okay, then we could have a look at B. B is vertically opposite the 27, so it must be the same, it's 27. C, we've got now a lovely triangle where we've got 90, we've solved B is 27, so we'll take those away from 180, and we're left with, let's say 62 degrees there. That cannot be correct as we're taking away the 27 there, so that should read 63 degrees, so apologies, that C is 63 degrees. Okay, that won't change the answers for the other ones there, but C should be 63 degrees. Now for D and E, we can solve these together. They are vertically opposite, so they must be the same angle. We know that B is 27, 27 plus 27 is 54. All of them together will make 360, so 360 minus 54 is 306. Divide that by 2, and you've got D and E, which is 153 degrees. Okay. Then we're left with F and G. F is nicely on a straight line with 108. They must add up to be 180 degrees, so F is 72 degrees. Then G, we've got one last triangle there, 72, 27, and whatever G is, so 180 minus 27 minus 72 leaves you 62 degrees. Angles in a triangle add up to be 180 degrees there. Okay, so let's just double check we've got those. I think again I've copied in the incorrect one there, sorry. My apologies again on this one. G there, it is 180 minus 72 minus 27, but obviously again 62 doesn't look quite right there. That should be 81 degrees. That should be 81 degrees for G. Just rushed a little bit there, and I think I copied the answer for C, which in fact was also wrong. So yeah, G is 81 degrees. Okay, just a little couple of deliberate mistakes there to keep you on your toes there, year 7. So what we've had a look at today then is you're able to calculate missing angles, so you should be able to solve that one on the right hand side, justify your missing angles with sound reasoning, and then solve some complex ones. So for example, again there's another shape to solve for F. Now for those that are still feeling confident with this, I have put in a bonus few questions on the end. Can you find the missing angles in the diagram on the right? So you might have to work methodically through, spotting all the triangles and all the various quadrilaterals and other shapes to see if you can solve, and potentially every single angle on that diagram. If you can get them all right, fantastic. By all means, send a picture to your teacher and they will have a look over that as well. And then there are 2 other bonus questions, little extension ones, for those who want to be pushed that little bit further with the angles there. So that concludes lesson 2 of the week. There is one more to come later in the week. Look out for the Hegarty clips as well. And in the meantime, look after yourselves then, Year 7.